In this lesson, we're going to talk about security and permissions. So this is how we're going to secure our workstations. So the first level of permissions that we have are going to be based off of our users and our groups. We talked about this yesterday in our Windows operating system lectures. That Windows has these user accounts, and they can place them in one of 4 basic group types. They can be a guest, a standard user, a power user, or an administrator. Now, if you have a guest, they have very little privileges. In most computers, your guest accounts are going to be disabled by default. Guests basically can log in and maybe get to the internet, and that's about it. Standard user is going to be your standard user. He's able to save files to his portion of the hard drive. He can run programs, he can print things, he can do all the things a standard user should be able to do. If you think of your normal employee in a business, they're a standard user. A power user is a standard user with a little bit of extra power to it. That's why I'm calling power users. So they might have the ability to, say, install a printer, or change a printer, or modify a printer. That's kind of a power user level type thing. They get minimal administrative rights, but not full administrative rights. And then we have administrators. And in Windows, the administrators are gods. Okay, administrator can do whatever he wants to the operating system. He can touch whatever files he wants. He can delete whatever files he wants. He can install programs. He can do all that cool stuff. So that's what we use at the administrators. So you don't want to run your account every day as an administrator, because if you're on the internet as an administrator and you pick up a virus, you just installed it as an administrator, which means it's going to affect all users on that system. It's going to really hose that system up. So instead, you want to operate every day as a standard user, and when you need administrative privileges, that's when you run your particular program as administrator to do those tasks. That's a best practice from security. With user account control in Windows Vista and Windows 7, what they were finding was most people were running as an administrative user. They weren't running as a standard user like they should. So what they did was they keep every user, whether you're an administrator or not, in what's called standard user mode instead of being an administrator. And then if you need to run something that needs administrative permissions, it's going to ask you for your password again. And at that point, you're running things as an admin. Like you can see here, for instance, I'm trying to delete a file that isn't necessarily owned by the standard user. It has this little shield next to the delete, which tells me it has to be run as an admin. When I do that, it's going to pop up and ask me for my admin password. It's basically a safety check. It's automatically going to run everything as if it was a standard user. If you need to do things that require administrator, it will prompt the administrator for the system changes. This will reduce the risk of malware being run as administrator and causing more damage to your computer. It's a safety feature that's been added to give more security to the Windows operating system. It started in Vista and it carries forward into Vista 7, 8, and 10. Least privilege. So least privilege is a security concept where we want to dictate that a user only gets the minimal privileges they need to do their job function. So for instance, you guys as students don't need to manage a printer. You need to be able to print to the printer, but you don't need to be able to install a printer or delete a printer or change the printer, right? If I'm the administrator for the classroom, I may need those rights. And so we'll put ourselves in different groups so that I can give you the least amount of privilege to do your job. Groups can be given permissions based on what's called a need to know or a need to access. So for instance, if we split up this class into, say, the payroll department on the left and the receptionist pool on the right, okay? Do the receptionists need to have access to how much everybody's getting per hour? No. Do the payroll folks need to know how much each person's getting per hour? Yes. So we'll make 2 different groups, payroll and receptionist. The payroll group will have access to that information. The receptionist will not. That's the idea of least privilege, right? But baby, both of you guys need the access to print to the printer. So we'll have you guys in a group called printers that can actually print to the printers. And so we'll give you groups and permissions based on what you need to do. With our file systems, we have secure and insecure file systems. We talked about this previously when we talked about Windows file systems. The 2 big ones that we deal with are NTFS and FAT. NTFS is our new technology file system. FAT is our file allocation table. NTFS was designed for security in mind. It lets you use the encrypted file system. It also allows you to do permissions to even down to the file or folder level, and I can choose individual users or individual groups that have permissions. With FAT, there is no file or folder encryption. There was no support for users and group permissions. So if I have a folder, it's either everyone can read it or nobody can read it. Everyone can modify it or nobody can modify it. When I dealt with NTFS, I could say Chuck can read it and Dave can write it and Joe can read it and write it. I can be very, very specific that way. With FAT, the local login provides anyone who has local access to the hard drive access to all of the contents. So just because I have the C:/documents and user/Dave folder, even if Joe logs onto the computer, he can still go into Dave's files that way. because of the fact of using FAT, which is why we always want to use NTFS. In fact, as of Vista, anything newer than Vista, I default. In fact, it will not support FAT because of those security risks. So in XP, you had the option of using FAT. But as soon as you went to Vista or 7, you had to use NTFS. So that way we don't have access to the people's files and folders, and gives us a lot more security. File permissions. So we keep talking about these file permissions, and we can assign those permissions to either groups or users. So here's an example. We have the system group, we have the administrators group, and we have John is a user. And right now I clicked on John, and I can see the permissions that this particular folder, which is the John desktop / folder, has. He has modify access, read access, listing contents access, read and write access. That means John has the ability to write it, read it, and because he can modify it, he can also delete it, okay? I can give him any of these permissions. Each permission can either be allowed or denied based on what we want to assign. And if I click on administrators, they might have full control and all of those things. If I added somebody like Sarah in here, maybe I'm only going to let her list the contents, but she can't read them or write them. So she can know if there's a file in there, but she can't open it. Or if I let her list it and read it, she could see that there's a file there and she could double click it and open it, but she couldn't change it, right? Those are different things that we can do with these permissions, and it gives you very good granularity to give your users permissions on these files. Inheritance. So when we have a folder, it actually inherits permissions from the folder above it by default. So if you change the parent folder, then the subfolders will also have their permissions changed as well. Just like your kids inherit things from you, right? Like, I have hazel eyes. That means my kids have a chance of having hazel eyes, right? Or if I have brown hair, my kids are going to have brown hair. If you move a folder, it's going to retain its permissions. So if I take something from the C drive /users/Dave, and I move it to C drive/data, it's going to keep those permissions that it already had. Now, if I copy that folder and I left the original in place and made a second copy, that copy is just going to get the permissions of whatever folder I put it into. It's going to inherit it from the one above it, okay? So copying, you're going to inherit. Moving, you're going to keep your old permissions, okay? And so when I'm talking about inheritance, if you look here, I have the C drive listed, and then I have Windows is a subfolder of C. So it's going to inherit permissions from the C drive. If I look at the add-in folder, it's going to get its permissions from Windows, which gets its permissions from the C drive. You can break the inheritance if you want and give it individualized permissions, but by default, it's going to inherit from above it, okay? And you can see that here in the advanced security settings for the folder, you'll see it says include inheritable permissions. You can unclick that and it'll say, are you sure you want to break inheritance? And you'll say yes. And at that point, you can add or remove permissions as needed, and it'll be individual to that folder. NTFS versus shared drive permissions. So there's two types of permissions that we use for our files and folders on our Windows systems. And we look at the cumulative permissions of both of these to figure out what permissions they're actually going to have. So for NTFS permissions, we're talking about local files and folders on the hard drive that you're dealing with. When you're dealing with shared permissions, you're dealing with the permissions for the shared files or folders on a network drive. And there's only three options. They're very, very broad. You either have full control, where you can read, write, and delete. You can have change control, where you can read, write, and delete. Or you have read control, where you can only read it. The difference between full control and change control is that full control also allows you to change permissions for other users, right? Change only lets you change the file itself. And you basically just check them. If you have them checked, you'll either get no access, you'll get share permissions, and then you'll get your NTFS local permissions. So when I look at a file, anything that says no, if it's a deny, it's going to deny me from getting it. So that's the first thing that we check, that no access. The second thing it's going to check is it's going to look at the share permissions. And so if I have allows in the share permissions, and I hadn't gotten denied in the first one, that's going to then get checked. The third one is the local permissions on the hard drive itself. So that's the order we checked. But the big idea here is that NTFS is your local permissions, shared drive permissions are over the network. File attributes. So we talked about attributes before. We talked about the attrib command back in Windows. Each file and folder has its own attributes. The two most basic ones are read-only and hidden, as you can see in this picture here, neither of which are checked, so this file has neither of those attributes. Basic attributes can be found under the File and Folders property box under General. If you click on Advanced, you'll see additional attributes. Things like System, things like Archive, you're the read-only, the hidden, different things like that. And again, this is just a graphical representation of what's been set by the attrib command. Data encryption in Windows. So we talk a little bit about the fact that there's this EFS, the encrypting file system, that comes by default with NTFS. It's supported by operating systems that can read NTFS drives, which is Linux and Windows can both read and write NTFS drives. Macintosh can read NTFS, but it cannot write NTFS. Data can be opened by users who encrypted them, by the administrator, or by somebody who's called the EFS key holder, and that's anybody who has the encryption key. You can export the EFS key for that person and keep it in a safe place should you ever need it. So if I encrypt an external hard drive using EFS and I lose that key, you're not going to be able to open that data without using special tools and cracking the encryption, okay? So you want to make sure you take care of that key. If you look over here under the advanced attributes, you can see there's that archive bit I was talking about, that top one. And then if you look here at the bottom, you'll see encrypt contents to secure data. If you check that, whatever user has checked it, it will turn the file name green, like this text file, or the folder green, like this encrypted folder. That shows you that that's EFS encryption on that particular folder. We'll play with this when we do the lab. I'll show you guys how we do this. BitLocker encryption. BitLocker is the newer version of encryption. It is much stronger than EFS. It only comes in the Enterprise and the Ultimate editions of Vista and 7. It's going to give you full disk encryption using 128-bit AES, which is Advanced Encryption System encryption. The key has to be stored remotely. So when you lock it with BitLocker, you're going to save that key either to a USB thumb disk or burn it to a DVD, something of that nature. Put it in a safe, and that way if you need to unlock that data later, you can. Data backups. So one of the big things with security is we have to make sure we have our data backed up. Data backups are necessary for a couple of reasons. The first and major one is mechanical devices fail. If you have a hard drive, it's spinning very, very fast, right? If it breaks and it no longer spins, you can't get the data off it. So mechanical devices will fail. That may be at 2 years, it may be at 5 years, it may be at 10 years. So you always want to have a second copy of your information someplace, okay? The other thing is that if you have these and you get like a big virus and you need to wipe your computer, you'll still have your data that you can restore, okay? Data is important. Most of the time we're not as worried about the machine itself, we're more worried about the data, because a lot of this data is irreplaceable. If you think of baby photos for somebody or home videos, those are things you can't just go to the store and rebuy, right? You can't put the kid back in the diaper when he's 18. It's not going to work. He's not going to be real happy about it. So your backups can be subject to hacking and tampering, so you want to make sure they're in a safe, secure place. Your backup data and drives and media should be password protected. You should encrypt it if possible using something like BitLocker. Your backup data and media should also be stored in a safe place. So one of the things that my family does is once about every 6 months, we'll take a copy of all of our photos and videos and put them on extra hard drive, and we ship it down to my wife's father's house, and he puts it in his safe at his house. And that way, if our house burned down and we lost our computer, we have an off-site copy of that stuff, so we only lose the last 6 months. Additionally, we also back up a lot of our stuff to the cloud. So we have Amazon Web Services, and we put all of our photos and videos up there. And that way we have an unlimited amount of space for about $50 or $60 a year. And that way, if our computer died or the hard drive dies, we can always re-download all that stuff again. And that way we have it in 2 different places that we trust. That way we know it's there and ready to go. Same thing, you want to make sure you do this. In business, we call this off-site backups. This will be done with either hard drives, tape drives, or a cloud service provider. Data migration. So when we're doing our data migration, we talked about the Windows Easy Transfer or the user state migration tool. Using a direct connection is best. So using a cable between the 2 computers is fastest. It's also the most secure. If you do it over a network connection, there's a possibility that somebody else can be on your network and capturing that data you're sending, right? And now they've got a copy of all your files. So if you use the File and Settings Transfer Wizard, which was the old XP version, it did offer a password-protected transfer of the files across the network connection. But again, you want to be careful because if it's just using a password and it's not using strong encryption, it may be cracked, it may be attacked. So again, using a direct connection such as the Easy Transfer cable, it works quickest and it works most securely. So which of the following is true about a file when it's copied from an NTFS to a FAT32 partition? The file owner is preserved, all of the file permissions are lost, all the file permissions must be reassigned, or the file name becomes case insensitive. What do you guys think? B, all of file permissions you lost, right? Now, why is that true? Because we said in TFS we can have all these very minute file permissions, right? I can say Dave has read permission and Joe has write permission. But with that, you don't have that. It's either everyone reads it or nobody reads it. So those two file set permissions are incompatible. So why is this really important? Because your hard drive is NTFS if you're running Windows 7, right? If you use a thumb drive, they're usually formatted as FAT for compatibility between other operating systems. So if I copy a file to that thumb drive, I just lost all my permissions on it, which means it's now full read-write.